Okay, so let's begin lesson 10.6 on tangent lines. So as a refresher, a tangent line intersects a circle at exactly one point, called the point of tangency. So first, looking over here to the left at this image, we have the tangent line that intersects with the circle at point A. So point A is the point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So if the line and the radius are perpendicular, then the line is tangent to the circle. So if we look here, we can see the radius of the circle would be PA or AP, and that radius along with that blue line are creating a 90-degree angle here. So that would show that they are perpendicular to each other. And so AB is tangent to the circle. Okay. So from that, we were able to understand that a line being tangent to the circle means that it has to create a 90-degree angle with the radius. So let's look at the even problems, and then you can do the odd problems on your own. So reading the directions, it says determine if line AB is tangent to the circle P. So for number 2, we're determining if this line here is tangent to the circle. So is this line and the radius, are they creating a 90-degree angle? Yes or no? So if they were to be, we're going to assume that they are creating a 90-degree angle and try to prove or disprove it. So if they were to be creating a 90-degree angle, that would create a right triangle. And for a right triangle, in order to be a right triangle, we have to prove that a squared plus b squared is actually equal to c squared. So if you recall, that is the Pythagorean theorem. So the smallest leg would be our A, the larger leg would be B, and then the hypotenuse would be C. Okay? First of all, we're given that this small portion of this line is 5. So in order to finish C, in order to find C, we do need the rest of the hypotenuse here. And since that does represent the radius of the circle, that piece does represent the radius of the circle, and we're already given that the radius is 11, so this is 11 as well. Because all radii in a circle are of the same length, because they're equidistant from the center. So that gives us that C is 16. So now we can just fill this in. We have a squared is 11 squared plus 14 squared equals 16 squared. Hopefully, we'll see. 121, here we get 196, and for 16 squared we get 256. Is that true? No. 121 and 196 gives you 317. Which is not equal to 256. So no, AB is not tangent to circle. Actually, we could just write the symbol for circle. Circle P. Looks more like an oval, but So recall that we're saying no because the radius and the so-called tangent line would have to make a 90-degree angle in order for that line to be tangent to the circle. And we've just proved that that is not going to be a 90-degree angle, because if it was a 90-degree angle, then it would create a right triangle. And we are not making a right triangle currently with those numbers. That is, we're not getting that a squared and b squared equals c squared. They do not. All right, so moving to number 4, we have if JK is tangent to the circle L, find X. So it looks like we're assuming that JK is tangent to the circle, then that will allow us to find X. So if JK is tangent to the circle, that means that the radius here, JL and JK, would make a 90-degree angle. And so again, we end up with this right triangle here. So we're going to be doing a squared plus b squared equals c squared. First of all, similarly to the last problem, we're only told that this piece here is 7. So we do need the rest of the hypotenuse. And that does represent the radius. So this is 11 as well. So it looks like we do not know the value of our longer leg. So this is A, this is B, and this is C. Okay? So we have, again, a squared plus b squared equals c squared. So we're doing 11 squared plus x squared equals 18 squared. And so we're just going to find those values. Again, we have 125 x squared, 324 for 18 squared. We're going to subtract 121 from both sides. And we get that x squared is going to be equal to 203. We need to take the square root of 203 in order to find that x is equal to 14.2. And that's all we were told to do, was to find x. So that's finished. On to number 6. In this part, I'm going to go ahead and stop doing the algebra portion of it. Unless the algebra looks a little different for the problem, then I may go back, but we're just going to do the geometry now. First of all, I'm told that the radius here is 11 again. So that means that this portion is 11 as well, because the diameter is MJ. So the diameter would be double the radius. And we're told that that hypotenuse there is 25. Okay, so we're solving for x. So we're going to say this is A, because it's the smallest leg. This is B, and then the hypotenuse is C. Oh, and sorry, I did leave out, of course, your radius and the tangent line will create the 90-degree angle, which is how I knew that the 25 is the hypotenuse, because it's across from the 90-degree angle. So we're doing x squared plus 22 squared equals 25 squared. And we get x squared plus 484 is equal to 625. And I'm going to go ahead and stop there, and you can finish solving for x on your own, but you should get that x is equal to 11.9. Number 8. With number 8, we do not know the radius of the circle. So this is also x as well. We have that the tangent line is JK, and that was just from the directions that we read earlier. If JK is tangent to the circle L, find X. So we're saying that JK is tangent to the circle. And the tangent line as well as the radius should create the 90-degree angle. So now I know that the smaller leg is A. The longer leg is B. And the hypotenuse is C. So we're doing 7 squared B is 2x. Oh, why am I writing equals? Sorry. A squared plus B squared is equal to C squared. And from there, the geometry is slightly different. The algebra, sorry, is slightly different. You're going to end up with 49 here, and then here you're going to have 4x to the second power. And having that second power there, you'll be fine. It's that 4 in front. You're going to end up having to divide by 4, so that's why I'm actually going to show the geometry for this part. We're going to subtract 49 from both sides, and we get that 4x squared is equal to 576, 625 minus 49. And then you just want to divide by 4. So when you do 576 divided by 4, you get x squared is equal to 144. And then, of course, you do want to square root both sides to get that x is 12. So that's one way of doing that. Or another way you could have approached it is by, this kind of looks like a T, so let me change that. It is an X. Okay, X plus X is 2X. But another way you could have done that was, instead of saying that this portion here is 2X, you could have said it's just Y, it's an unknown length, and then of course take whatever you get for Y, you will have to divide it by 2 to say that that is what X is. But yeah, either way, X is 12.